Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 67, I chat with Joe Kane about his new 3D test patterns and building his home theater. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded May 23rd, 2011, episode 67, 3D Reality. This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies streamed to your PC, Mac, or TV instantly. Plus, get DVDs and Blu-rays by mail in about one business day. For your free 30-day trial, go to netflix.com/twit. And by hover.com. Hover is domain name registration and management that's simple. For Hover's transfer concierge service, free for our audience, go to hover.com/HTG, offer code HTG. Hi there, Scott Wilkinson here with UltimateAVMag.com and HomeTheater.com. This week's guest geek is Joe Kane, one of the world's foremost video experts, making his second appearance on the show. Hey, Joe, welcome back.
Thanks. It's good to be here.
Now, the reason I have you here is that we've got a lot to talk about in terms of 3D and also your new home theater. So we got a lot to cover. Those who are tuned into the live video stream at live.twit.tv or into the chat room at irc.twit.tv can post questions for Joe, and I'll pass on as many as I can. So let me start with 3D. This whole movement towards 3D, stereoscopic imagery, what do you think of it overall? Is it worthwhile?
It's a difficult question to answer. I haven't been a fan of what I've been seeing up to this point. I think it can be a lot better than it is, and when it becomes a lot better than it is, I think I will become far more enthusiastic than I was, say, at day one.
Mm-hmm. Don't you think that's partly because it's a new art form and people are still sort of getting their chops together on it, and maybe they haven't quite got it all together yet?
Oh, that has a great deal to do with it. That it's almost everyone who is involved in 3D is looking at it as a new art form, and I think they're still playing with it to try to determine what's going on. Certainly, the A-list producers of motion pictures are doing far better with it than they were, say, a year ago. So things are progressing on the production side at a rapid rate. Right.
Now, have you been to many 3D presentations in commercial cinemas?
I have only been to a few. There are, as an example, I'm not enamored with some of the technology that's being used to present 3D, and I don't particularly care for it. Therefore, when 3D movies are being presented in those formats, I don't go just because I don't care for the technology that's being used to present the 3D.
Which is your favorite of the technologies?
Certainly Active is my favorite, followed closely by the Dolby Color system, where you don't have issues with the screen. And this is, of course, for motion picture presentation in theatrical environments.
Right. I recently saw Thor twice, actually. Once at an Active Glasses theater. The ArcLights here in LA use the Expand system. And once in IMAX, which is a dual projector polarized system. And the one thing I really didn't like about the Active system was it was so dim. It was just dark as all get out, whereas the IMAX system was a lot brighter. Now, granted, the IMAX system, you need to have a special polarization preserving screen, which has its own problems, but it sure looked a lot brighter.
I understand that overall brightness is an issue in the game and getting to 3D. And one way or another, that's going to have to be resolved, whether we just end up having to put brighter bulbs in or get more efficient active glasses. I'm not quite sure what the final solution will be, but it's, as you pointed out, 3D is still in its infancy. And as we progress in time, there are more and more approaches to making 3D work.
Mm-hmm. Turning to the home environment, we have several different technologies there as well. We, in terms of flat panels particularly, which is mostly where the action is these days, we have active glasses flat panels, and we have passive flat panels, and two different kinds of passive flat panels now that Samsung has made its recent announcement. What are your thoughts on those various technologies?
Well, the passive technology where you end up having to take half the resolution of one image, and meaning the left eye, and half the resolution of the right eye, and put them on the screen at the same time, certainly has some limitations, and I honestly expect consumers to be able to see those limitations. Mm-hmm. So at the moment, I'm not enamored with the passive approach, where we're doing it with a single panel and using half resolution. Obviously, in the future, there's going to be something known as active passive, where the active part is on the display and the passive part is in the glasses. That certainly should improve the condition of being able to wear passive glasses.
Right. Passive glasses are generally preferred because they're lighter, they're less cumbersome, less bulky. They're certainly a lot less expensive. But putting the active part in the TV would then make the TV more expensive, wouldn't it?
I don't have a good answer for that, because what I'm seeing reported is completely the opposite. That in theory, if the panel will run fast enough, there is effectively zero cost in doing active in a display device. The passive panels require a filter to go over the top of the surface of the set, which theoretically would add cost. So from what I'm reading in the press and what I understand, the passive display is actually more expensive to build than the active display. Now, it isn't priced that way in the marketplace. As you probably know, some of the passive displays are less expensive than the active displays. So there's no accounting for cost versus price.
Yes. Good point. Excellent. Very good. Now, that brings us to the whole issue of reviewing 3D flat panels, which is an area that you have recently started to address. You came over to our studio and showed Tom Norton and me some stuff. Recently, last week, we went to an event at DreamWorks Animation, a beautiful campus, by the way, where Samsung was holding a day-long reviewers workshop, wherein you showed us there, too, some of your new test patterns. Now, I have to say, for those who don't know, Joe is famous for creating video test patterns that are used to evaluate the quality of a video display, how well it does this versus that, one thing and another. And he's created many discs under the umbrella of Video Essentials, or more recently, Digital Video Essentials. And your website, videoessentials.com, is where people can get these discs, right?
Yes, that's certainly where they can find a link to it. I don't actually sell the discs myself because I don't want to compete with distributors, and so there are links on my site to where they can purchase the discs.
Okay, great. And very recently then, in these two events that I've attended, you've showed us now what you have developed in terms of 3D test patterns, which are sorely needed. Those of us who review 3D TVs don't have any really good way yet of evaluating their performance with these certain kinds of test patterns that you have now come up with and will soon make available. So I'm very excited about that, and I'd love to go through some of them with you. Tell us, though, first your overall view of testing 3D panels. How should we go about that?
Well, among the many things in 3D that I'm concerned about is it comes out and there are no personal expectations of what it should be. There's the wow factor of seeing dimension in the picture, and all too many times people tend to evaluate or make judgments about what they're seeing with no foundation, no idea of what it's supposed to look like or what to expect from it. So what I'm trying to do is get people beyond the wow factor of 3D as quickly as possible by saying, if we're going to evaluate the quality of a 3D set, let's take the approach of going step by step leading into 3D. In other words, determining what the display is actually doing before actually watching something with a z-axis, something that has dimension. So I'm starting out with a position that, first of all 3D displays have to do 2D, and that the 3D will probably not be any better than the 2D capability of the set. So we start by evaluating the 2D capability. And oh, by the way, I honestly want people to see the reception and display of 3D as actually the display of two 2D images. There's a 2D image for the left eye, and there's a 2D image for the right eye. And I want them to use the heritage of everything they know about evaluating 2D and just apply it to 3D.
Makes total sense to me, since 3D, as it applies to TVs and movies, is really a simulation. As you say, it's a combination of two 2D displays. So the best 3D that it can produce depends on how well it does 2D.
That's the way I'm seeing it. And I also believe that if people understand that, they can get beyond the wow factor of 3D much faster and see it for what it really is, and therefore their expectations would go up because they have a lot of experience with 2D. And if they look at 3D from a 2D perspective, I think 3D is going to progress in quality much faster than if we have to deal with them getting over the wow factor.
Right, right. Now, I've always said that if you want a good 2D set, this is sort of coming at it from the opposite direction. If you want a good 2D set, you might want to consider getting a set that is capable of doing 3D, because generally speaking, a manufacturer will put 3D capabilities in its best 2D sets. Have you found that to be true? Generally speaking, generically speaking.
If you want to be generally speaking, yes. The one caution there is the approach to 3D, the approach that each manufacturer is taking to 3D could influence the way that set performs in both 2D and 3D. And at the moment, I'm taking the position of active versus passive. I've already intimated that most of the passive displays that exist now try to display both the left and right eye simultaneously. And if you've got a 1080p display, and you've got a full resolution left eye and a full resolution right eye, the only way that you can display both simultaneously is to subtract half the lines from each image. Now, if a set has a predisposition to filtering half the information out of each image, the question then becomes, what does it do in 2D? If it has to do this in 3D, unless there's a completely separate circuit for the 2D versus the 3D, which then, of course, becomes expensive on top of the fact that the panels are more expensive, I'm not going to say absolutely because it's a 3D set that it's going to be better in everything. In fact, I can find examples where, because it's 3D in passive in particular, the 2D capability isn't anywhere near as good as 2D sets from that same manufacturer.
Good point. That's a good point. Alex Santos in the chat room points out that 1080p ends up being 540, which it does. It's exactly what you're saying. It's 540 in each eye. Not only that, in my experience, looking at such a set, even through the 3D glasses, I see these very thin black horizontal lines that indicate that each eye is really only seeing half resolution. We actually have a picture that shows exactly this point. I believe it's called Glasses. And if John can pull that up, we'll be able to see exactly what we're talking about. Oh, unfortunately, it's a little, at least on my display, it's got some moire, but tell us about what we're seeing here.
Well, again, what we've done here is we put up a flat field. And a flat field, of course, means that every single line is active. And
right. With the same color, in this case, white.
Right. It's a flat field white. And so what happens is when we take out half the lines from each image, we're taking out half the vertical lines. And vertical, of course, is transitions in the vertical direction. So right. We're actually removing horizontal lines. So when you look through the glasses, the left eye, even though it's a flat field, the left eye only sees 540 lines. Now, the right eye sees another 540 lines, but from the other image, from the other half of the image. Mm-hmm. So when you put the glasses on, the left eye sees 540 lines, and the right eye sees 540 lines. Now, there's been some suppositions that these two sets of 540 add together. And of course, they don't, because if they did, you wouldn't see any 3D, because there's a difference between the left eye and right eye. And if the left eye doesn't see just the left eye information and the right eye seeing just the right eye information, you won't see 3D. So anybody who has the philosophy that, oh, gee, 540 plus 540 equals 1080, therefore it's full resolution, is crazy, because 3D wouldn't work if that was the case. Mm-hmm. And so, what you're seeing in those glasses, when you put the glasses up, you're seeing half the lines being delivered to the left eye and half the lines being delivered to the right eye. And your brain is conscious of the fact that half the lines in both the images are missing. Therefore, yes. It's truly no better than 540.
Right. Alex Santos in the chat room also asks along these lines, so to speak, does the 540 line interlacing occur at a frequency so high that it's not noticeable? And the answer really is no.
All right. And once again, you have to see each image individually. Now, he's using the word interlacing, and the presumption is that the interlacing he's talking about is the fact that the two images are interlaced. One of the things to keep in mind is both images are on the screen simultaneously. The half lines from the left eye and the half lines from the right eye are on the screen simultaneously. So it doesn't matter what rate they're flashed at you. Right. They're both there at the same time. So half the lines are gone. That's the beginning and end of everything.
Right, right. Now, so this leads me to ask you about your new 3D test patterns, most of which are what you call 3D flat, which means they're not really 3D. They're the left eye and the right eye are exactly the same. Tell us about that.
Well, I'm trying to take an approach to 3D step by step, coming away, as I said, 3D is nothing more than two 2D images. All right, so once we go to 3D, if we want to evaluate what the display is doing independent of the glasses, we put up images where the left eye and right eye exactly match. What, as you pointed out, what I'm calling 3D flat, meaning that everything is in the plane of the screen. Now, in this set of circumstances...
Before you go on, let me just quickly explain that to see 3D, you have a depth. You have what's called the z-axis, and you can put things in front of the screen or behind the screen or right at the screen. And the things that are right at the screen are perfectly coincident. That is, they overlay each other perfectly. If they come in front of the screen or they go behind the screen, they diverge. And you see two images start to diverge as they get farther and farther away from the screen plane. But at the screen plane, they're exactly coincident, and that's the kind of images that you're talking about here.
That's absolutely it. And one of the great things about 3D flat is it allows you to evaluate what the display is doing independent of the glasses. That's a critical part of 3D, is knowing what is being delivered to the glasses before evaluating what the glasses are doing. So it's a twofold thing. Number one, you can evaluate the quality of 3D displays independent of the method of presenting 3D, because you're truly evaluating the two 2D images. And number two, this 3D flat concept allows you to evaluate the quality of the glasses. You can tell what's coming from the display and then look to see what the glasses are doing to what's coming from the display. So this concept of using 3D flat gets you way beyond the wow factor instantly, allows you to compare technologies, as an example, active versus passive, or just a whole bunch of active technologies. It allows you to objectively make comparisons of what the displays are doing, and then of course it gives you isolation so that you can then look at the glasses independent of the display.
It's very cool, actually, to be able to see test patterns that are driving the set's 3D mode, essentially, that are telling the set, oh, this is a 3D image, it's got a right and a left, but you don't have to be wearing the glasses to look at it. You can be looking at it without glasses, see what it's doing, and then put the glasses on and say, oh, they're color shifting, they're making it dimmer, they're doing this or that, one thing or another. It's really an excellent approach, I think.
It's critical, in my opinion, to actually understanding what's going on. And I say that from the perspective of too many people are attributing things. They put the glasses on and they say, oh, wow. In other words, the wow factor of 3D. and they don't get what's actually happening. They attribute attributes, that's two words, same thing, but anyway, yeah, right. they think they're seeing something when it's actually a combination of what the display is doing plus the glasses. If they know what the display is doing first, then there's no issue of determining what the glasses are doing. There is a reality to what the glasses are doing rather than a supposition that, oh, gee, I'm seeing this effect, this must be happening.
Right, right. Now, Alan Mitch in the chat room asks, so do your patterns let us adjust color and tint and brightness and contrast? Have you developed those in 3D flat yet, or are you mostly looking at resolution and stuff like that, which we'll show a picture of in a second?
No, I have not left out common adjustments. First of all, a large number of sets have completely separate adjustments for 3D than they do 2D. So it's absolutely critical to have patterns in 3D, 3D flat, in my opinion, yes, to make basic adjustments. Now, granted, you have to make some adjustments like grayscale, and actually grayscale is probably the biggest one that you have to make through the glasses. Right. But and the glasses have to be active, incidentally. If you have active glasses, they have one color in the off mode and they have a completely different color in the on mode. So when you're doing grayscale, a true 3D signal has to be coming from the set in order to make this work. And so I've taken my commonly available 2D signals and I've made them into 3D flat. So all the test patterns that you're used to for calibrating everything in the TV set is now available in 3D flat, so that you can do the basic calibration with or without glasses.
Mm-hmm. Let's take a look at one of your resolution patterns. I just want to show this as an example. I believe it's called resolution. We'll find out in a minute. There it is. It's the SMPTE resolution chart. And what's great about it is that it gives you all kinds of information, including brightness, how the brightness changes from black to white, and in particular resolution, horizontal and vertical. In the lower left quadrant of that image, it may be hard to see on the screen, but you've got horizontal and vertical, what are called bursts. There they are.
Those are in the center of the image as well. Those are actually in the center of they're in the center and they're at all four corners. And the reason for that is we want to often look at resolution at both the center and the corners of the image. Mm-hmm. So what you're seeing is you're seeing full resolution, half resolution, and 1/3 resolution in both horizontal and vertical. Now, the great thing about this test pattern is they're independent of each other. Horizontal exists independent of vertical. So you can look at the two independent of each other.
Mm-hmm. And then there's also in this, is the pixel phase also in this pattern?
No, the pixel phase is in a different pattern.
Different pattern. And I should just describe it then. I don't think I sent it to John. It's a combination of the horizontal and vertical test patterns, such that in the finest resolution, you have it like a checkerboard of individual pixels.
That's correct. It's simultaneous horizontal and vertical information. Now, one of the things that I've discovered is oftentimes a display will not function well at all when it's being delivered simultaneous horizontal and vertical information. But if you look as an example at the detail that's in someone's skin, it's neither horizontal or vertical. It's both simultaneously. They both occur simultaneously.
Right.
It's both simultaneous. Yeah.
They're in there. Yeah, right.
Yeah. In any event, so it's important to me to have both independent horizontal and vertical, plus a combination of the two happening at the same time. And that way I get to look at how well the set handles both independently and both together. Mm-hmm. Now, one of the test patterns that I've modified, the overscan test pattern, and in the 3D version of it, I've actually included both simultaneous horizontal and vertical resolution pixel phase, and I've included horizontal and vertical independent. So in setting the sharpness control, which affects all of this, you can actually see what's happening to horizontal and vertical resolution independently and together as you're adjusting the sharpness control to get rid of all the extra edges that are in the picture.
Gotcha. I'm sorry I didn't send that picture up to John to show everybody, but I do understand your point. I've got a few. Sorry, go ahead.
No, I was say hopefully if people know my material, they know the overscan test pattern and they know the pixel phase test pattern. And I've just taken elements from the SMPTE RP133, the pixel phase test pattern, and put them into the overscan test pattern.
That's actually a great idea, and I'm looking forward to using that very much. We have some questions in the chat room, but before we get to them, I want to take a moment to thank one of our sponsors for this show, which is Netflix. Netflix delivers movies directly to your home and saves you time, money, and hassle, certainly over brick-and-mortar stores. You can instantly watch thousands of TV episodes and movies streamed directly to your PC or Mac or stream to your TV or a Blu-ray player, Netflix-enabled Blu-ray player, or a game console like Xbox 360, PS3, Nintendo Wii. And if you're still into discs, you can get DVDs and Blu-rays by mail in about 1 business day. You can watch as many movies as you want, anytime you want. There's never a late fee, and no due dates. So no streaming out to the store there to return that disc or VHS. Our Netflix streaming pick of the week is something that I enjoy very much, which is Craig Ferguson. Does this need to be said? Those of you who stay up late and watch late night comedy know Craig Ferguson from his show, The Late Late Show on CBS. One of my favorites, certainly, and he's a hilarious guy. And this program is stand-up comedy with uncensored material he can't use on network TV. You can instantly watch this movie or choose from thousands of TV episodes and other movies when you register for a free trial membership. Go to netflix.com/twit. Be sure to sign up for your free trial at netflix.com/twit. And we thank Netflix for their support of Twit. So, Joe, I've gotten a couple of questions in the chat room about high frame rate 3D. James Cameron's been talking about it. Peter Jackson apparently is filming The Hobbit in 48 frames per second in 3D. Do you think this is really going to be one of these advances, one of these moves forward that is going to improve 3D?
Well, certainly IMAX, as an example, has been using 48 frames for a considerable amount of time. So it's certainly...
Do they actually use 48 frames? That they are, when they show a movie, a standard movie like Thor or whatever, that wasn't captured in 48 frames, right?
No. I'm actually talking about IMAX presentations.
Okay. IMAX sourced material.
Yes, IMAX sourced material has been at 48 for some amount of time. Of course, the larger image and the amount of power that's necessary, 48 has given a much smoother image than 24. I certainly have been a fan of increasing the frame rate for some time, although I openly acknowledge the artistic point of view that people are used to telling stories in 24 frame. There is, the wheels have to go backwards. The spokes on the wheels have to go backwards, or it's not film. 48 frames is going to be a lot better in image quality than 24. There's no question of that. Did we lose Scott?
Yeah, we did for a second. Sorry, I muted out for a second there. Now, would you go to 48 or would you go to 60? There's been some talk of either one of those frame rates.
You probably know that ShowScan was in 60 frames per second, so there's certainly a precedent for it. But right. A number of years ago, we actually tried to move from 24 to 30. And of course, all the 50 hertz countries in the world, those people who are locked to the line frequency, objected because there's no easy conversion from 30 to 50. I certainly want to see a faster frame rate. I even believe from the 50s, if you've ever seen Oklahoma in Todd AO, which is a 30 frame format, it is so much better than the 24 frame material. So even going from 24 to 30 is a spectacular move. And of course, ShowScan was absolutely spectacular in 60 frame. In fact, most people came out of ShowScan believing that they had seen 3D. In other words, they were attributing qualities to the image that weren't there in reality, but it was so far beyond their wildest expectations of what could be done in a motion picture presentation that they were attributing 3D quality to this 60 frame per second image. Of course, if they ever got used to it, they'd realize that it's just 2D. But
right. People often say that about increased resolution as well. If we go to 4K, for example, 4K 2D, a lot of people say, "Oh, that looks really 3D."
I I say that in past tense. I wanted 10-bit 422 to come to the high definition market right from the beginning. In other words, our video right now is 8-bit, and I wanted 10-bit, and instead of the 420 that's on Blu-ray, I wanted 422. And it turns out...
By the way, before you move on, let me just quickly say 422 and 420 are very geeky terms, referring to how the color is encoded and compressed, and 420 represents more compression than 422. 444 is literally essentially uncompressed, but it requires so much bandwidth that it's not practical. 422, right, I suppose, is practical, but they chose to do 420 because it consumes less bandwidth, but it also results in a lesser picture quality.
Actually, the interesting thing is that the people who decided on 8-bit 420 were analog people. No. And they thought don't take this. Sometimes digital is better. But what happened is that there was a lack of understanding that when you have to compress things, the compression scheme looks at artifacts and looks at imperfections in the picture. And it turns out the higher quality the source is, the less difficult the signal is to encode. So something 10-bit 422 versus 8-bit 420, gee, 8-bit 420 in analog terms is a lot less information. But unfortunately, there are artifacts created by that low resolution. So 10-bit 422 actually takes a lower bit rate to produce a better image than 8-bit 420. And so the joke is that the higher rate, the better quality input is easier to compress than the poor quality signal that they chose to use. And when I was first working and trying to bring high definition to the consumer, I wanted 10-bit 422 because knowing if you feed a better signal into the encoder, it takes less bits to come out with an equal quality image. So we would have had a far better high definition system if it hadn't been for these analog people who had decided, oh, lower amount going in must be lower compression, lower bits per second. And it's far from the truth that you get better quality by putting a higher quality in at the input and making it easier to compress.
Right. Getting back to frame rates for just 1 second, I just wanted to mention that I heard Douglas Trumbull, a very famous visual effects guy who worked on 2001 and many movies over the last 30, 40 years. I heard him at the SID conference last week, Society for Information Display, advocating for 120 frames a second. That if you do that, you get even better picture quality to begin with, but a much sharper motion. But also you can downscale it if you need to 60 or 48 or 30 or 24 by combining certain numbers of frames together and eliminating other frames. And he thought that was really the most effective frame rate to start with, to then be able to get it into whatever format and frame rate you wanted.
I certainly understand that. And of course, Doug Trumbull was behind ShowScan, which is the 60 frame per second rate.
Exactly.
And when we were back in film, 60 was about as fast as we'd ever want to run the projector and still expect the film to hold together.
Right.
I don't disagree that 120 frames could be a common format. It's certainly way above our temporal ability to see motion. So all of us, no matter what our persistence of vision at 120 hertz, would see a motion level that is far better than well, it would certainly be the limit of our vision.
Mm-hmm.
In fact, at one point, 60 hertz was considered pretty close to the limit of vision. But as you point out, 120 hertz has a lot of division rates that makes it easier to translate it to a lot of different display formats.
Mm-hmm. Mm-hmm. I want to take one more moment to look at one other pattern that you have created, and then we're going to move on to your home theater and its construction, which is also a fascinating story. But it's the image of the house that is actually the back of the Biltmore Hotel, I think you said, in Santa Barbara.
Yes, it's the grounds of the Biltmore Hotel.
Right. So if we can take a look at that image. Oh, here's the
side-by-side.
This is the side-by-side.
It's a real close-up.
And it's a serious close-up. If we take a look at the original first, which is just the picture of the hotel, we can see that it's a white Spanish-style house with plants and a garden and a railing. There it is.
There you go. Yes.
Now, this was a picture that I think you took, actually.
Yes, I did.
And then what you did with it was something very interesting, and that's the left-right one that we saw a little earlier. Tell us what you did with this picture.
Well, I took the picture and compressed it horizontally. In other words, squeezed it in half so that I could put a left eye image on one side and a right eye image on the other side, so that I could emulate the side-by-side transmission format. Of course, I can also vertically compress it so I can emulate the top-bottom format of transmission of 3D. The reason I'm doing images is because everybody says, well, you know, test patterns are one thing, but when it comes to images, that's something else. And I'm trying to say that once you know what you're looking for in test patterns, I can then put up images and you'll see the same thing. And initially, it's easier to see that in still images. So that's my starting point. And eventually, when I get to my 3D disc, the Blu-ray, yeah, I will have my own 3D motion material. I'm going to have highly controlled motion in 3D so that we'll have an opportunity to evaluate what we're seeing rather than, you know, some action movie where things go by so fast you can't figure out what's going on anyway.
Right.
But the attempt here was to say, can you see the same things in test patterns in real images? And by, once again, taking it one step at a time, you see the test patterns first, then you see the still images, and once you know what you're looking for, you can't miss the same kinds of things that you're seeing in the test patterns. It's a step-by-step introduction to the reality of 3D.
Yes. Now, the one thing you did with this one picture that I was so fascinated by, in addition to that side-by-side and over-under thing you were talking about, you took two copies of the same image, you eliminated the even-numbered lines out of one of them and the odd-numbered lines out of the other one. And if we can see the left-right image on the screen, which we saw a moment ago, we'll be able to see what that looked like. And if you zoom in on it, we'll be able to see that the lines alternate. So we'll have to zoom in pretty far. There you go.
Yeah.
So why did you do that?
Well, the purpose of doing this was to pre-filter, if you will, or create the image that passive 3D has to create on its own. So there were actually multiple reasons for doing it, but among those reasons was to determine, first of all, how much the image is degraded by the passive processing in the set. In other words, if I present the set with exactly what it expects to put on the display, what does it do with that signal from the input to the output? A second reason that I created that image is a number of passive TV set manufacturers claim as much as they're removing half the lines from the picture, they're actually creating an interlaced picture out of the left eye. In other words, in one period of time, they're showing the odd number of lines, and in the next period of time, they're showing the even number of lines. Well, in this particular case, if all the even lines are black and all the odd lines are image quality, then what you're going to have, if they're actually truly trying to interlace, you're actually going to have some extreme flickering, because it's going to be black picture, and it's going to constantly go back and forth. So this particular pattern makes it easy for me to test if they're actually doing that. There are a lot of claims being made that they're doing it, but this is a method of determining for real if it's actually happening.
Mm-hmm. It's a fascinating approach that I had not thought of before, but it really works well, as we saw in some examples in the studio as we were looking at it, and some other examples. You can actually see whether or not what they're claiming they're doing is actually happening.
Well, and that's certainly been a part of my heritage in the industry, that all the test signals that you see in my disc are a reference for what the system says it's supposed to be able to do. So in theory, you should be able to put up these test signals and it should work. 3D, there's lots of unstandardized, if that's a word, there are non-standardized approaches, because there aren't any standards for 3D.
Yep.
And so everybody's taking their own approach to making 3D happen. So basically, they tell us what they're doing. And so I design test signals to find out if that's actually what they're doing. But I've been doing that for my whole career.
Exactly. And those of us who test TVs and really want to know what's going on certainly appreciate it very much. We're going to spend the last few minutes talking about your home theater, which is a great story in and of itself. But before we do, I want to take a moment to thank the other sponsor for this show, Hover.com. Hover's all about making domain registration and service simple. They don't sell a ton of services. They focus on making it easy to register and manage domains and email. Even better, they have a new no-hold policy for customer service calls Monday through Friday, 9 a.m. to 8 p.m. Eastern. When you call, you'll get a live person, and they won't put you on hold. Here's an exclusive offer for the TWIT audience, a free transfer concierge service. Hover is offering TWIT audience members free domain transfer, no matter how many domain names you have. It's a $25 service on the site, but just call Hover, give them your username and password, and they take it from there. They'll get the authorization codes, deal with all the emails, let you know when your domain names are on Hover and working exactly as you want them to. The transfer itself is $10 per domain name, and this extends the domain 1 year beyond its current registration date. For the TWIT audience, Hover will handle the whole hassle of transfer for you at no additional cost. To get this free concierge service, call Hover's customer service number listed on their website, which is Hover.com, and all you need to do, and if you need a new domain, get 10% off by going to hover.com/HTG and using the offer code HTG. We thank Hover for their support of this show and TWIT in general. So, Joe, in the last few minutes here, I want to go over talk a little bit about your own home theater. You moved a couple of years ago into a beautiful house. And if we take a look at a couple of the before shots, we will see what the room looked like before you tore it apart, tore it down and built it back. Here it is, white walls, big windows.
This is as it was staged by the real estate company. That picture is actually before I bought the house.
Oh, okay.
And when I came in to look at it, the real estate company had staged the house for whatever reason. Right. Now, this is actually
looking towards the back.
Yeah, I'd moved in by this point, and the room is open to the kitchen in the back, so it's a family room.
Right. And then work began, and we see a couple of construction shots here where things got a little messy, I think.
Yes, I basically needed acoustic treatment in that room, and so rather than punch holes in the wall or try to do anything, I decided to hang the acoustic treatment on the surface of the wall. But then, of course, I didn't want that to show up, so I had to build a structure to support fabric that could go over the top of the acoustic treatment.
And that's what we see there.
Yeah, you see there is the frame structure that supports the fabric. And of course, this also allowed me to add down lighting from the ceiling. It allowed me to surface mount the roll screen, without having to cut holes in the ceiling. I just mounted it to the surface of the ceiling because the ceiling had to come down anyway to support the fabric. So it hid the screen. It made wiring really easy.
Mm-hmm. Alan Mitch asks, as I asked you before, wouldn't the open back cause sound problems, that open back of the room into the kitchen?
Actually, the interesting thing, of course, is that you want a diffuser in the back of the room. And the kitchen ends up being the perfect diffuser. Well, perfect. It's a really good diffuser. So it worked to my advantage having the kitchen back there. We originally thought we might have to draw a curtain across and put a diffuser, but when we started making room measurements, it was essentially what I needed. So the kitchen is the perfect diffuser on the back end of my home theater.
What do you know? What do you know? Let's take a look at a couple of the other acoustic treatments before the final covering went on. I know we've got a couple of those pictures sitting there in the folder somewhere. There we go. Oh, there it went. There it was, and there it went. Here we go.
Yeah. Well, you can see diffusers and absorbers on the ceiling that also the absorbers on the ceiling are spaced down away from the ceiling. So they're not only absorbers, but they're also bass traps. So the spacing away from the ceiling of the absorbers gives me a bass trap. And then, of course, there's diffusion directly over the seating area.
That was that triangular looking structure there that we saw a moment ago.
Right. So I'm using a combination of absorption and diffusion. You can see on the wall next to the fireplace, to the left of the fireplace, you can see I've got absorbers on top and I've got diffusers on the bottom. Well, it turns out that at speaker height, I've got the absorbers placed where the high frequency content comes out of the speakers, and I've got the diffusers placed at the level where low frequency comes out. So I'm diffusing low frequencies and I'm absorbing high frequencies. The room still sounds alive, but is tightly controlled acoustically.
Mm-hmm. Mm-hmm. And then one of the things that you had to do, of course, was redo the heating, ventilation, and air conditioning system, because that's one of the surprising areas of noise that can really impact a home theater. And I think we have a picture of the heating and air conditioning system on your roof. You had to install 2 different units there?
Well, a number of things. First of all, the heat exchangers are on the roof of my house, and the old heat exchangers were directly coupled to the house. In other words, that platform was locked into the house, and they were sitting directly on it. And the new air conditioning units, which incidentally were quite a bit larger than what went out, are now acoustically isolated from the house. They're setting on a 2-inch fiberglass pad, which of course is covered by the metal sheet that you see there. And then there are cork pads on the air conditioners themselves. So there's vibration isolation to the metal pad, and then there's 2 inches of fiberglass, compressed fiberglass for more isolation. So there's now no acoustic coupling of the air conditioners themselves to the house. The units are much larger than the originals, so that the fans in the air conditioning system itself can be turned at a lower speed. So when the air conditioning comes on in the home theater, you feel it, but you do not hear it. I can have everything else off in the room, nothing running whatsoever. And when the air conditioning comes on, you absolutely feel it, but you don't hear it. So it's absolutely dead quiet, which was the goal. I actually hired people that specialize in doing air conditioning for post-production houses to do this house, because they know about requirements to have the air conditioning totally silent. You put air conditioning in a Foley room, which of course has to have, and that air conditioning has to be totally silent. And so I hired people who do that for a living and understand airflow and ductwork, and we completely redid the air conditioning system so that I could have really quiet operation in the home theater.
And then, so finally, we end up with a few pictures of the finished product, in which you have put a dark gray material over the acoustic treatments, and we see there some uplighting sconces. Your drop-down screen has come down, and I put black behind the screen. Originally, I thought that that was going to be necessary, and of course, then I found that I had to backlight the wall because the amount of light I've got coming off from the screen is so high that I had to backlight anyway. So that black didn't need to be black in the final results. Incidentally, the sconces aren't on when the home theater is being used, just the downlighting. Right.
And there is downlighting behind the screen to light up that back wall.
Oh, you believe in bias lighting even for a front projector then?
Oh, I have to. Basically, human factors teaches you that the threshold of dark to light in a totally dark room is about 16 foot lamberts. Incidentally, the magic number that is used for setting up open gate in projectors. But
in commercial theaters.
In commercial theaters. Anything above 16 foot lamberts, if you truly have dark, the transition from dark to light is so large that it will create eye fatigue in transitions. So almost everyone needs backlighting at a 20-foot Lambert level, and 16 seems to be the threshold of where some people seem to need it. I'm running 23-foot Lamberts off my screen, which means I have to have backlighting. It's way too bright to not have the backlighting. Now, I did that because this is my TV set, and when I'm in the kitchen, I need a bright picture to be able to really see what's going on from the kitchen. So it was easier just to add a backlight, so I don't have to readjust the projector for when I'm watching in the theater versus in the kitchen. With the backlighting, it's all the same, and so I don't have to make any adjustments to the projector for lights on versus lights off. Right.
Alan Mish rather asks, do you run a 5.1 or a 7.1 system?
I have a 7.1 system. Actually, I have a 7-channel system. The subwoofers aren't here yet. So
your speakers are Revels, right?
Yes. I have the Ultima 2s, and they do a really nice job of handling low-frequency information. The subwoofers aren't available yet in the Ultima 2 product line, so I'm running a 7-channel system, and of course all low-frequency information is currently in the front channels. I don't have as much control over the bass as I will have when subwoofers come in the system.
Right. And just to finish up the other major equipment in the theater, you're running the Samsung projector, which you helped design.
Yeah, I'm running my projector.
Right, exactly. Yeah. and your screen from Daylight.
Yes, that's absolutely true.
Which is a Daylight Affinity.
Yes, and I'm using the 0.9 gain screen. I've got a 7.5 foot wide image. Incidentally, the size of the image was dictated by the acoustics. Kevin Vakes, who designed the Revel speakers, came in and helped me with this seemingly impossible room. And he determined that there was only one position that the speakers could go that would allow me to acoustically treat the room and come up with a really good room. And so we measured the distance between the speakers, and that became the image size. So acoustics dictated the image size in my room.
And what is that image size?
It's 7.5 feet wide.
And 16 by 9.
Yes, it's a 1:7.8 aspect ratio, and it's the 0.9 gain affinity screen. And so the video package is mine, the projector and screen combination, which is critical. Most people who have been here have told me it's one of the finest images they've ever seen anywhere.
Well, I would have to agree with that because I have seen quite a few images there, and it is truly outstanding. And I really wanted to give people a quick look at the process you went through to convert a less than ideal room into a superb home theater. And with that, unfortunately, we've run out of time. In fact, we've gone a bit over. So I want to thank you so much for being on the show.
Thank you. It's my pleasure to be here.
Now, as I mentioned before, you can get information about Joe's various projects and his discs and so on at videoessentials.com. My online homes are ultimateavmag.com and hometheater.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott. Next Monday is Memorial Day, so we'll be taking the day off. In 2 weeks, my guest geek is scheduled to be Jeff Murray, president of SpectraCal, developers of video display calibration software, and really quite an interesting fellow, so I sure hope you will join me for that. Until then, geek out.